Okay, so this is what we are doing on Tuesday. It's kind of carrying on from Monday. So we'll do a couple of examples. Okay, first one, I given this function. Okay, and we're asked to find the domain, range, and sketch. Okay, we know for domain, it's all x that are real numbers, all x that are real numbers, whose outputs are also real numbers. So what's under the square root has to be greater than or equal to 0. Okay, now this is a quadratic inequality. We can solve it in a couple of ways. One way is you could expand this out first, or factor it, right? Factor it, find the zeros, make the table and do it. Or what we will do is we'll just make a sketch of it and be able to see what's going on. Okay, so first thing we need to find though, when is this 0? When is the expression equal to 0? Okay, and so we have this x minus 3 squared to the other side. Take the square root. So x minus 3 is plus or minus 3. Because again, remember, this would give us x square root of x minus 3 squared is absolute of x minus 3. The square root of 9 is simply 3. And then we have the two cases, right? When x minus 3 is positive, you leave it alone. And when it's negative, it's multiplied by a negative. And you could move that negative to the other side, right? So that's where we get this. Okay, so x is negative 3 plus 3, or x is 3 plus 3. So x is 0 or x is 6. These are the two x-intercepts. So that is when this expression on the left is, sorry, have allergies, is 0. Okay, now we know the graph of 9 minus x minus 3 squared. So let's just recap. That's the graph of x squared, right? We have first flipped it across. So now it's negative x squared. Then we shifted it to the right by 3. Again, by replacing x with x minus 3. So this becomes this guy. Okay. And then we bumped it up by 9. Correct. And so we get this. We get this graph. Okay. But the x-intercepts were at 0, so my graph is kind of wrong. X-intercepts at 0 and 6, right? That's this guy. Okay, now what is the vertex of this? Well, we shifted this guy, which was 0, 0, flipped it, so it's still 0, 0, moved it to the right, so it became 3, 0 by 3, and then up by 9, so it's 3, 9, right? So this is 9. Okay, and this is x is 3. Okay, that's the only graph that's allowed because x has to be, the domain is x is between 0 and 6. Because that's where it's positive, right? That's where 9, the graph of 9 minus x minus 3 square is greater than or equal to 0. Okay, can't have the other parts here. Okay, this should be enough for us. So domain is 0 to 6. Now for the range. Okay, so what are we doing to this graph? I'm going to just do it this way. Here is 0 and 6, right? And this was on the x-axis, correct? And this here was 9. We took this guy and said we're going to take the square roots of all the y values, right? So this 9 will become now 3. Square root of 9, right? Square root of 0 is still 0. Square root of 0 is still 0 here. At x is 0 and 6. So we kind of squished this graph. It does get higher a bit here and there. Okay, but just squished kind of, Okay, or now what are we doing to this? We are multiplying all the y values by 5/3. So that's going to make it like this. Stretch it out a bit. And where is our height going to be now at? Is 5/3 times 3, which is 5. Okay. And then finally, what are we doing to this whole thing is bumping it up by 4. So we end up here, the x and y axis, we end up here 4, 2, 6, 0. And this one will become, the 5 will become 9. So we can see the ranges clearly from 4 to 9. Hope that's okay. Now we'll do the same thing for the other one, which was number 2. Y is equal to negative 5 root 3 square root of 9 minus x minus 4 square, what was it, x minus 3 squared, sorry, plus 4. Okay, we don't have to go through the same thing again. We know the graph of this. We said first again, 9 minus x minus 3 squared has to be greater than or equal to 0. We found the zeros were at 0 and 6. And now we can just look at the graph and see this graph looks like this. This graph looks like this, which we had 0 to 6. Right, we're only keeping the positive part is the domain is allowed. Okay, so we kick out all of this. So domain is just from 0 to 6 again, nothing changed. But the y values now. So what are we doing to this guy? First, we took the square root of it. So this will damp this down. And we get, that's a 3, right? Square root of 0 is still 0. Square root of 6 is still 0. Square root of 0 is still 0 here and here. The y values, we're taking the square roots. Now what are we doing to this graph? We are multiplying all the y values by 5/3. So it'll make the graph like this. So 0 times 5/3 is still 0, and this will become 5. 5/3 times 3. Now is the next part. If we are taking the negative, we're replacing y with negative y, right? So this becomes this guy. Okay, so that means we are flipping the graph over the x-axis. So this becomes that. So here it is at negative 5. And then what are we doing to this graph is bumping it up by 4. So this will be at 4. X's are still zeros, right? And this graph will be, this is at negative 1. From negative 5, bump it by 4 to negative 1. So the range is from negative 1 to where this bump up to is 4. So that's okay. And finally, let's put it all together. I said, what is the conic which has these two pieces as their functions? So we can pick either one of them and do it. So I'm going to just do it with the top half. Let's bring the 4 to the other side. Square both sides. Okay, let's multiply both sides by 9 over 25. Just, you'll see. Again, you can do this whichever way you feel want to do it. So this becomes just 1, and we get this. Okay, let's divide both sides by 9. Add this guy to the other side. And we have our ellipse, right? And remember, for ellipse, so let's get a practice of sketching this. Let's say you're getting this. We know for an ellipse, a square minus b square is equal to c square. A is always bigger than b, and a is bigger than c. So this should be my a square is 25 and b square is 9. So that's my a square, that's my b square. And you know, again, to check with the originals, without a transformation, this is what it would have been. And if you replace x with 0, so with 0, so we get y is equal to plus or minus a. So that means the a's are your, if you're replacing x with 0, so your a's are your y-intercepts, right? And that's being shifted. So basically your a's are on the vertical. So now we can sketch this. Let's see, the center was at 3, 4. Okay, the A's go up, the A's are on the Y's. So the A was 5, so we go up 5. So that's a 4, and 5 up is 9. And the B, let's go down 5. Okay, the B was 3, so we go 7. Oops, 3 plus 3 is 6. And here it's 0. And you see, you can make a box if you wish. Our A's and B's, same as when we do with hyperbola. Okay. And connect. Now this you can see is the graph from up here. Okay, that was the 5/3 square root of 9 minus x minus 3 squared plus 4. And then we have the other piece, which was negative square root of 5 minus 3, negative 5/3 square root of 9 minus x minus 3 squared plus 4. Okay, that's it. I'd like to do maybe one more. Let's do uh, let's do this. Let's do y is equal to 4 times square root of x plus 1 minus 3. Domain, range, and sketch. Okay, so domain is straightforward. X plus 1 has to be greater than or equal to 0. So x is greater than or equal to negative 1. Okay, so domain is negative 1 to infinity. Okay, the range, I can see, firstly, we can talk this through first. The square root function, right, is always square root give it positive or 0. So when x is, the smallest value of this is 0, but that is when x is -1. So then we get y is -3. And then square roots of bigger numbers are bigger positive numbers, times 4 is bigger positive. So we keep adding bigger numbers, positive numbers to -3. So we are going to positive infinity. It looks like the range is going to be from -3 to infinity. We can do this again by looking at the graph also. So here is the graph. And again, you should know your graph. This is the graph. I'm going to do 1, 1, 1. This is the graph of the square root function, right? Square root of x. What's the only transformation? We shifted this to the left by 1. So this is the graph now. Okay. We just want to see behavior. And then what are we doing? Multiplying all the y values by 4. Okay. So this will become 0, still stays 0. Everything else will get stretched. Right? And that will be the graph. Okay. Maybe it's good to get at least the y-intercept correctly. So when x was 0, we had square root of 1, that's 1. So this was at 1, we multiplied by 4, so that's at 4. Okay. The graph. And then finally, what are we doing? We're bumping it down by 3. So the graph's going to look like this. 3 versus -1. 4 will come down to 1. Right? And graph will look like something like this. So what's the domain we can see is -1 to infinity, and the range is, smallest value here is -3 to infinity. Okay, and that's kind of the sketch. Well, you should do the sketch a little, because if we have to sketch it, let's sketch it a little nice. We had at -1, it's -3. At 0, it was 1. Okay, and let's do one more point, which will be nice. Let's say when x is 3. When x is 3, that is square root of 4, which is 2. 4 times 2 is 8. 8 minus 3 is 5. 3 is 5. So this graph looks a little wonky, right? It's going to look like this. Okay. Okay. Now we do the negative piece of this. Y is equal to -4 times square root of x plus 1 minus 3. Okay. And same thing. Domain is still -1 to infinity. And now what are we doing with the square root graph? Maybe good idea. Let's do it with 3 points on it. 0, 0, 1, 1, and 4, 2. Okay, graph. And we are first multiplying everything by 4. So it's still 0, 0. This will become 4, 1. Sorry, 1, 4. Y values by 4. And this will become 2 will become at 8. All right. And then we're taking the opposite of it. We're replacing y with negative y. So it becomes the reflection over x-axis. And then we are bumping it down further by 3. So this is what we're going to get is -1, -1, we're going to be -3. Okay. And let's see, at 0, we're going to be, so it's going to be basically the flip of that graph. This one at 0 was 1. Ah, my graph here was not correct. Sorry. To do this is very important. So what is this? At -1, we are at -3, right? At x is 0, we are at 1. That's why I put it at the wrong place. X is 0, we are at 1. When x is 3, we are at 5. Now this makes better sense. It's the graph. Yeah, it's not wonky. That's the graph. Now we have similarly here when x was, this will be the shape of the graph, and once you bump it down, so let's see at -1, this is -3. At x is 0, that's square root of 1 is 1, so -7. 7. Okay, and we could have done one more point, and you can do it with transformations also. And so now let's pick it when x is 3. When x is 3, that's square root of 4, that's 2, that's -8, and -3 is 11. And x is 3, it's 11. Okay, that's the sketch. Domain was -1 to infinity. The range we can see is -infinity to -3. And we can see that here, -3, we are subtracting, right? Quantities. This is getting bigger and bigger. So we're getting more and more negative. From -3 is making it even more negative. And this would be the graph. And looks like if we piece it together, if I take this piece and I put it here, guess what we're going to get is our parabola. Okay, so let's come up with the equation for that. So we can pick either one. So I'm going to pick positive. If you want, let me show it with the negative. This guy, -3. Let's add the 3 to the other side first. Square both sides. Negative square just becomes positive. This becomes 16. And that's it. Okay, so this is the form y square is equal to, the original is y square is equal to 16x. We know this is y square, it's not a function. X has to be positive, so it's this guy. Shift it to the where the vertex, instead of being at 0, 0, the vertex is at -1, -3, which is what we had, and we know the shape. We should use the focal width, the focal, so the focus, so the original focus would have been at, so what's the focus, what's our P? So 4P is 16, so P is 4, so your original focus is 4, 0. With the transformation, now the new focus is to the left by 1 and down by 3, the 3, -3, -3, okay? The focal width, remember that is 4P. right? Because again, focal width is if you take any parabola, here's the focus, P, and we know that the distance, the vertex to the directrix is P, and vertex to the focus is also P. Okay, and now if I have this, I want to find the length of this width. Okay, so here the distance to the directrix is 2p. So this is 2p because that's a definition of parabola, distance from a point to the directrix, and a point on the parabola to directrix and the point on the parabola to the focus is the same distance. So this is also 2p. So 4p, so that is equal to 4p, that is p was 4, so that's 16. So that means from here we have to go up 2p, which is 8. And we go up, so that's 3, 1, 2, 3, 4, 5. There's the point actually. So it's going like this. And from here we have to go down 5, 3, 5. It's at negative 8. And I think that those are the yep, that's it. That okay? All right. Why did I have here negative 311? Sorry, 3 comma negative 11. 3 negative 11. Let's make sure this is correct. So our focus is at, the original focus is at 4, 0. Oh, we shifted to the left by 1. My God. We shifted to the left by 1 and down by 3. So focus is 1, negative 3. 1, negative 3 is the focus. Okay, so then up by 4, 2p is 8. 2, 3, 4, 5, 6, 7, 8 there. And down by 8. 8. Here by 8. So this is going to be the, okay, let me do this part again. Sorry. So yeah, the original would be y squared is equal to 16x, where 4p is 16, so p is 4. So the focus would be at 4, comma 0. But we've shifted to the left by 1. So it's, oh God, sorry. Maybe it's because first thing in the morning. Okay, I'm doing this now. So you shifted to the left by 1. So it becomes 3 and down by 3. So I was correct. 3, negative 3. So 3, negative 3. That's the focus. The vertex was at 0, 0. So that will go at negative 1, negative 3. Okay. Now this is negative 3. We have to go 2p up. P is 4, so you're going to go 8 up 3. 5 and go down 5. Go down 8. So sorry. So yeah, that's fine. So that's at negative 11. Everything was correct. The first time I just added wrong. That's the shape, which is what we had in the original also, right here. Okay. All right. That's it. We'll stop here.